Hello everyone, and thanks for joining me. Today we're going to talk about Solidworks to GibbsCAM, taking your design or assembly into GibbsCAM so that the pieces and the parts can be manufactured easily. I'm Steve Offenbaugh, Senior Applications. I'll be taking you through this for the next 20 minutes or so to try to give you an idea of what we can do and how it's done. Ask questions if you like. We'll try to answer them as we go. Ones we can't get to, we will certainly get back to you. And we're also recording this, so for whatever reason, if you have to leave the presentation or if there's someone who can't make it that you know would be interested in this, be able to go back in and watch it. Perfect. So SolidWorks to GibbsCAM. The idea here is to take your files, your assemblies, your design, move them into Gibbs so they can be manufactured. And that's the bottom line here. We want to be able to do that easily without any translation. And that's the key, is that we're not translating anything. We're physically reading the SLPRT file or the SolidWorks file directly into Gibbs, and we'll be machining it. Okay? Pretty simple stuff. All right, so let's see how this really works. So let's start with a version of SolidWorks open, of course. And this is the design we're going to use, something simple just to give you the ideas of what it can do. And we have an add-in here, a GibbsCAM add-in. And what happens is when you install Gibbs, here under Tools and Add-ins in SolidWorks, we put a add-in in the SolidWorks product so that you can transfer the files to Gibbs. Okay, it's a pretty simple thing upon install now. And if Gibbs and SolidWorks are on the same seat of software on the same computer, this will appear and you'll be able to transfer back and forth, no problem, eh? If not, we can just run the add-in on the seat that doesn't have Gibbs, and when the file is saved, it allows us to read in all the features and all those kinds of things. That's really what we're after here. Okay, I want you to take a small note of the feature tree here. Okay, so we have boss extrude, cuts, and some chamfers, and I want you to pay small attention to that as we transfer this file to Gibbs. So what I'm going to do here is click on the add-in and transfer to Gibbs. Now what's going to happen here, Gibbs is going to open up and the file is going to get transferred. If there's already a file there, it will ask you a question. Do you want to insert it, replace it? In our case, we're just going to transfer. And there's the file. So easy peasy. So what I'm going to do here is select this face, and I'm just going to align it to a coordinate system. So again, that should show you that inside of Gibbs, or I should say inside of SolidWorks too, doesn't matter where the part is. You can design anything you want in SolidWorks. We'll bring it in. We can easily align it to something that we can use to machine the part. So now there's a couple of different things we can do here. Old school, we're going to start with that first, and then we're going to move on to something that's a little bit cooler. All right, so first, let's look at the features. Remember the feature tree that we just looked at? Here in Gibbs, we have something called the feature manager. And when you transfer a file or open a file in Gibbs, we automatically see all the features that have been created in SolidWorks, okay, which is very cool. What we don't want to have to do is when we go to machine these pockets or the chamfers, is we don't have to want to pick this over and over again. We want to take advantage of the features. And we don't want to do a lot of work either, right? We want to have the software do a bunch of stuff for us. So at first here, I'm going to do this what I would call the old school way, or what people can do, okay? Or people do today. The reality is all things Gibbs, we allow you to do whatever you want to do, however you want to do it. Okay, so if you want to do it this way, that's fine. I'm going to show you a couple other ways you can do some process stuff that works even cooler to make this thing work even to your advantage, more to your advantage, I should say. All right, let's just create a tool. You know, again, this is just all things Gibbs, shrink fit tool. That's good enough. We'll bring tool down and we're just going to do some roughing. Okay. Now, the one thing I'm going to do here is you notice that this says automatic. So under this tab here called Mill Feature, we set this up here, incremental, and we set the top and the depth to automatic. So now it knows something about the pocket, makes it easier for us to machine this pocket. All we will do is set a desired step. Let's just say half an inch. Half an inch tool. Let's just do 100,000 good. And I'm going to pick cut extrude 1, which is that pocket there, and I'm just going to say do it. And there you go. So I read the file in, and this is what's important. I've read the file in, don't know anything about it, don't know its size, don't know anything. I'm going to guess at that radius. I mean, I could check it, of course. Don't know the depths, widths, anything, and able to just click and go. Software smart enough to know. Okay, so that's one way to do this, and we could check all these different radiuses and you know, build the tools accordingly. But again, I don't want to do that either. I want to do it a different way. So for now, let's just toss this stuff away. For now, okay. So now what I have done is we have gone in and we have created a couple of process steps here that make this so much easier. I don't even have to think about it. Okay, so if I want to rough this pocket here, I would select it. And I would just select this basically process that I've created. And it builds the tool based on the radius. And it machines the pocket. And I can do that all day long. Okay. So these two pockets are the same radius in the corners, so we don't create another tool. However, this one is a little different. So you'll notice the step overs are a little different, step downs are a little different. Now, this is a sample of what you could do with a process and a macro. Okay, and this is done for a sample, so you can go in there and adjust. I could adjust it however I want to adjust it. For this, it seems to work well, and it makes it look very, very cool. Okay, so quick and easy. So this is one way to do this by taking huge advantage of these features that come from Solidworks. All right, so let's do this now. Let's do the chamfer. Again, you could already guess that I've created a process here that does the chamfer. So there you go. You can see the chamfer right there. Perfect. And in this case, all of these chamfers are tied together. So I can do multiples. All right. I don't have to just do one at a time. I could do multiples. And I'm going to use a different tool. And I get this message. Okay. Now this message is not an error message. It's a message that says the slice body has succeeded, which means that the toolpath that it generates is lines and arcs. In most cases, when you're machining on a solid, unless you can filter the toolpath, you're going to get a point-to-point data, especially in the corners. This allows me to create G2, G3 moves, G1 moves. So basically analytic geometry. It's very cool. And I'll say okay to that. So now what we've done here is we've roughed out the pockets and we've done some chamfering. So let's go to our OpSim and let's have a look at how it looks. And what I'm going to do is turn on the op colors so we can track the colors of the operations. So you can see what's going on here. And so there you can see the first one is red and then yellow and then blue for the 3 pockets. And then you see the purple. Now, I noticed something here. In my case, for the roughing, I actually leave stock. And I notice here in the corners that I have a problem. I left some stock. So now I have to go in and do some contouring on that. So imagine what I have to do now. You know, I'd have to go back in. I have to pick all the faces. Yep. Nope, that's not what we're going to do. We're going to do basically the same thing. I'm going to select this, and I have a contouring macro process to go in and cut the contours on all these parts. Okay, and I put that slice offset body in there. You don't have to, but I like it. I think it works really good for generating analytic toolpath. So you can see here that we've done all three. Now what's cool here is, though, even though I've done all this and I've kind of done it a little bit out of order, I can manipulate everything here. In fact, I could take these three toolpaths, which is really what I want to do, and I'm going to move them up above the chamfers. Because that's really what I want to do. I want to have a nice and clean cut and toolpath, you know? So if we go through and we look at this again, you can see now that we've cut the inside of the pockets with a contour, the right depth, the right size. Chamfers look beautiful, and this part's basically done. I mean, there's lots and lots and lots you can do. So again, the idea here is quick and easy. Now I'm going to do one thing just to make it complete. I have, by request, as we do with a lot of things from customers, something pretty simple. But let's go ahead and let's face off the part, and let's cut the outside. And let's do it all at once. But what I wanted was a few choices. Okay? So we built this little macro that says, do you want to create the stock, yes or no? And you can put values in there. In this case, I'm going to say no. And there's a couple of reasons why we would say yes or no. I have another macro that creates a vise, that creates its own stock. So maybe I don't want the stock. Again, we try to let you, the user, be a bit more creative in kind of the things that you'd like to do. I do want to face off the part. You don't have to, but I like to, because that's really what we want to do here. 3 different types of end mills. You could have 6. You could have a pull down. You can make this anything you want. And then contour around the outside. I'm just going to use a 1/2 inch end mill around the outside. And I'll just say okay to that. And so basically it goes out and it creates a toolpath across the top. And it creates a contour down the side. So very, very easily done. And it's quick. And this is kind of nice. Now again, it's a little bit out of order. So I would take this up here, move it around. And then we can look at our op sim. And that went kind of fast, so let's rewind that really quick here. There's our face. There's our cut around the outside. And the other cool thing about this is, even though some of these things are put in there 100% like this, okay, so it's quick and easy and poof, it's in there. If I wanted to change something, if I didn't like it, for whatever reason, I set it up, really don't like the way it is, maybe we change a material, maybe there's 100 different reasons. Every one of these processes is editable, so you can edit it and then just rerun it, and it's okay. Again, giving you that flexibility to do all the things you need to do to get the job done easily and quickly, and that's the key here. Okay, so that's a nice looking part, quick and easy, simple stuff. Let's go ahead and open up another file here. And again, we can open up a lot of different files, but here we're going to do either solid SLPRT or the assembly file. We're just going to do a Solidworks part, and I'm just going to open up this part here. And again, the orientation is no problem. Okay, so we're just going to pick a face. I'm going to pick this face here, and I'm going to align that to the CS. Quick and easy. So it doesn't really matter how you design the part in SolidWorks, we can bring it in and manipulate it very quickly to get it in the right location. And we'll switch on the CAD color. And this is another interesting thing. You can machine the parts by colors if you like. We can build a small macro that allows us to go in and look at a color. Say, hey, you know, all the colors that are purple, for example, do this type of pocketing or do this type of contouring or. And I think we've demonstrated that in the past. So again, a small refresher, but if you're using SolidWorks, we read all the stuff in, and that's what you need to understand, is that we read all the data in, okay? As well as the PMI data, if you need that as well. Okay, so as you can see, we have these, what appear to be lines. These are smart lines, or smart points, or features, actually. People call them different things over the years. These are really features. Okay, so each one of these was drawn in SolidWorks using the whole wizard in SolidWorks. Okay. These four here do not have the feature line, and that's because they were just some extrusion. Okay. You can also see all the features here, right, in the feature manager. But in this case, because these are holes, it's much better to look at them in the hole manager. Because here now, what I could do in the hole manager is I can group them together. So all like holes, or I can set up some parameters, and I'm just going to group them together. Oops, sorry. Let's auto group those together. So now I have grouped them together. Okay? And if you click on the group, you can see how they're grouped. It finds all the like holes and it groups them together. So again, quick and easy, makes it really nice. So let's go off and let's have a look at this. And if we look up here, you can see it's a bit grayed. So it's a 532 hole. So I'm going to guess, if I had to, that this is 4.5 inch socket head screw, just because of my knowledge of what size it should be. Okay, so let's do that. Let's just do that as a 1/2 inch socket head. Perfect. The only thing I want to check, and again, we have to keep in mind what we're doing here, is that we have no idea how this was made. Maybe the engineer just hands you the file and says, here you go, and you have to decide how to manufacture the part. We don't care how he builds it. We can manipulate it and make it work. And that's really another cool thing, is we don't have to say, hey, gee whiz, you have to do it this way. So let's look at the order of these holes. And they kind of go, 1, 2, 3, 4, 5, 6, 7. And that might be okay. I don't know. We could do closest to next. And it does a little bit different. And that might be okay too. Let's just do that. Okay, I'm happy with that. And I'm going to go in, and in this case, I'm going to use my own processes. Okay, so I have a process manager here, and I'm going to go in and I'm going to find where I keep my processes. And here's my process. I'll just select that folder, and there they are. And I'm going to use my 2-segmented 1/2 inch, and it loads the tools in the process, and just say do it, and we get a drill and a helical bore. And more that's what I see people doing. So this is just another way inside of SolidWorks, when you bring the files in, how we can just bring them in and machine them. This here, these are 1/2-13. In this case, I can just use what we call auto whiz. It'll go off and it will automatically drill and tap all the holes. You can see they're scattered all over. I would have to go back in and line them back up. Okay? What we want to take away from this is the fact that we can use features, we can use the whole features, we can use all these things from SolidWorks to quickly and easily manufacture our parts.